In part E, the question is, a perspective projection transform requires a division operation. This is true. So in the perspective projection, we can use similar triangles to relate the height of an object on the screen X, where the object is actually in world coordinates, height H, and at location Z, along Z-axis. And then the imaging plane or screen is at F, focal length. So using similar triangles, the relationship here would be F over Z equals X over H. So if we want to solve for, let's say, the coordinates in screen space, then we can solve this equation for X and get H F over Z. And so there's a division here in Z. Part F, the Catmull-Rom spline can be used to interpolate a curve through a sequence of points when the tangent to each point is not known. This is true. So Catmull-Rom interpolation estimates the tangents from triplets of points. Part G, the four inputs to cubic Hermite interpolation are the positions and tangent vectors of the endpoints of the curve. This is also true. So in cubic Hermite interpolation, we assume we're given at, let's say, x equals 0 and x equals 1, we're given the value of the function f of 0, f of 1, but also f prime of 1 and f prime of 0. So given the tangents, then cubic Hermite interpolation will fit a cubic polynomial to these four constraints. High-order Bezier curves are popular for interpolating complex paths in animation. False. High-order Bezier curves using many control points are not popular. They're quite difficult to control. Also, the Bezier curve won't pass through the intermediate control points, making it potentially unwieldy to reason about what the curve will look like. So instead, animators will use piecewise Bezier curves. In part I, the question reads, in the loop subdivision scheme, the number of extraordinary points increases by 4 after every level of subdivision. This is false. The loop subdivision is going to preserve the degree of existing vertices. In the loop subdivision scheme, the smooth limit surface that results after a large number of subdivision steps will pass through the vertices of the original mesh. False. Loop subdivision is an approximation scheme that will result in a smooth limiting surface. It's not an interpolation scheme that will preserve exactly the values of the vertices of the original mesh. Otherwise, we would still have quite a blocky mesh potentially. A Monte Carlo estimator for a definite integral is unbiased if the expected value of the estimator is equal to the value of the definite integral. That is true. So what we had seen before is that the Monte Carlo estimator Fn is equal to a sample average over n samples, where we sample random variable xi. So here xi is sampled from some distribution p of x. But then the Monte Carlo estimator weights the samples by the density given. So if we sample more rarely from some points, if we sample rarely from some points, if we do happen to sample, then we should highly weight the contribution to the integral. And then the definition of this estimator being unbiased is that the expected value of fn is going to equal the actual definite integral we would like to compute. So let's say over some interval a, b of f of x dx. Part L reads, to create a probability density function that is proportional to a given function, we must divide that function by its definite integral over the domain of the function. This is also true. So in order to, let's say we have some function f of x equals x squared. This is the example used in lecture. We would like to estimate some proposal p of x that is proportional to f of x. But in order to compute what this density is, we'll need to normalize it. And that's where this normalization constant c comes from, and it's computed by integrating f over the interval. Part M, in importance sampling, the goal is to avoid sampling a function where its value is large, to reduce variance of the sample values. The answer is false. In importance sampling, we are actually trying to sample a function where its value is large, not try to avoid sampling the function where the values are large. Part N is photometric quantities are zero for light of far infrared wavelengths. So photometric quantities, as opposed to radiometric quantities, only measure properties of light for visible light spectra. And so the far infrared wavelengths are not part of visible light spectra, so they won't be accounted for in the photometric quantities. So this will be true. The irradiance on your cheek decreases as you tilt away from the sun. This is also true. Another radiometry or photometry question. So this is also given by Lambert's cosine law, and the idea would be the irradiance on some surface, E equals phi over area, will be maximum when the surface normal points in the same direction as the incoming light. And the irradiance will in fact be given by a cosine theta factor here as the surface tilts away from the sun. And so when theta is equal to 90 degrees, the irradiance on the surface will fall to 0. Part P reads, a bounding volume hierarchy is not an appropriate acceleration structure to use for a scene composed of a detailed teapot in a stadium. This is false. The bounding volume hierarchy would be quite an appropriate acceleration structure to speed up rendering of this scene. And when you have a detailed teapot in a stadium, this is an example given in lecture, where the scale of the objects is very different and the concentration of objects is highly non-uniform. So there's a lot of detail at the teapot, a ton of empty space. And so using a uniform partitioning of the space would be quite inefficient. The bounding volume hierarchy, in contrast, groups the scene at the level of triangles, objects.